Okay, so last part of the week, we're going to take a look at section 1.2 and a little bit of 1.3, and we'll end up finishing 1.3 next academic week. So, first thing they mentioned in section 1.2, it's kind of a general process when you have any kind of problem, you have to think about solving, how to go about it. So first thing, when you read over a problem, two things that you want to make sure of is that you understand the information that they're giving you and what they're asking you to find. Now, sometimes writing down what is given, that also means maybe assigning it a variable, right? So maybe it has a name to it, or if it's an unknown, maybe you have to give some kind of name to it, right? So we'll go through that in our next problem. And then we have to decide how we're going to go about solving it. Sometimes sketching a picture, okay, that's a good approach. That would work well if you had like a trig problem, and you said, there's somebody standing, and the angle between where they're standing and the top of a building is 40 degrees, and they're standing 300 feet away from the building. How tall is the building? It's a perfect problem to draw a triangle and solve from there. Okay. Sometimes making a list can be helpful. Like if I said to you, tell me all the different ways you can arrange the letters A, B, and C. You could list them all. There's only 6, so it's not bad. But sometimes lists can get kind of big, so there's a limit to how big of a list you really want to have to make sometimes. Almost every problem that's a word problem involves setting up and solving some type of equation. Sometimes the equation you set up will be something that's familiar. Maybe it's an equation, there's a common one that we use, like distance equals rate times time. That comes up in physics. It also comes up in different topics, maybe in math a little bit. So it might be a formula that already exists, and you just have to figure out how to plug into it. Or it might be a formula you have to figure out the whole thing from scratch. There is no kind of preset formula. You've got to figure it all out. And then once we decide on how we're going to solve it, then we go ahead and try that method, see if it works. And sometimes the original method you thought doesn't work. So you've got to go back and try something else. Right? Sometimes that's one of the hardest things, because a lot of times people don't always think of multiple ways to solve a problem. People tend towards one way that they think is going to work, and sometimes they can get stuck if that way doesn't work. So it takes a lot of practice to get good at trying to come up with a completely different way to solve something. Usually easier to do when you work in groups, because then two people might have totally different ideas. All right, so first example we're going to look at, and we are going to do a little bit on the calculator with this, so I see most of you have one, so we'll use it in a little bit. It says, write an equation to model the following. A company charges $15 to rent a car, and then they charge 20 cents per mile, because that's per mile that you drive it. So how many, we're going to write an equation. And the first thing is, how many variables are going to be in that equation? Think about how many things in this problem are unknown. Yep, Sarah?
How many cars and how many miles?
Okay, how many miles? Yep, so how many miles you drive is unknown. And what does that determine? How many miles you drive helps to determine the... Yep, Jake?
The final cost.
The cost. So those are the two variables. We're going to do a little bit with graphing, so let's use x and y. So y is the total cost, and x is the number of miles driven. So I want to write an equation using these two letters. If my equation is going to predict what the cost equals, how should I start my equation? What would be the first thing I write, Ashley?
Y equals.
Yeah, it would be y equals. And what would go on the other side to represent a $15 charge to rent the car plus 20 cents per mile? Yeah, Chris?
15 plus 0.2 times x.
Yeah, and I'm going to do it like this. It's the same thing Chris said. He said 15 plus 0.2x. I did 0.2x plus 15. Both answers would be correct. Anybody know why I did it this way? Yeah.
That's easier to graph than any other way. Y equals mx plus b.
Exactly. That's in y equals mx plus b form. So it's already set up to graph if we need to do that in a later part of the problem. But for now, that's all I wanted. That's an equation that models that situation. Any questions on that? So we basically just went through that whole problem solving process. We looked at what was given, right? We gave names to what was unknown, and then we decided the method here. Well, they told us the method. Write an equation. So we already knew what we had to do, but we just had to do it. All right, so now let's use that model that we just came up with to predict the cost for a couple different scenarios. Right, let's say you drive 50 miles. Ethan, how would I use the formula that we just wrote to figure out the cost for 50 miles?
We'd substitute x for 50.
Yeah, we're going to substitute in the 50 where the x is. So we got y equals 0.2 times 50 plus 15. Okay, if you think of 0.2, that's 2/10. 2/10 is the same as 1/5. So in my head, to do that, that's really like 1/5 times 50, which is 10. So 0.2 times 50 is 10. 10 plus 15 is 25. And it's a word problem, so I should have some type of label. Tyler, what's my label on that? The 25 what? Well, what did we just find? We used the model to find
The total cost.
the cost. Yeah. So what's my cost measured in this problem?
Dollars.
Yeah, it's just measured in dollars. So the cost is 25. We need to put a dollar sign. All right. Now, how about for 100 miles? Double the miles. Can I just double the cost? Say 50. Done. What do you think, Matt? Can you just say $50?
Now that you added the 15.
Yeah, we don't want to double the 15, right? We only want to double the mileage part of the cost. You don't want to double that 15. So you can't just quickly say it's going to be double. It's not going to be double. All right, so let's figure out what it is. So we have 0.2 times 100 plus 50 plus 15. So that's going to give me 20 plus 15 or 35. And again, that's dollars. Okay, so any question on using our equation to figure those out? So that equation, that 0.2x plus 15, that's called the algebraic representation of our problem. By writing that, it kind of takes the word problem away from it. Somebody could walk in the room right now and look at this, and they have no idea that that's about renting a car. And you pay, 20 cents a mile. All they see is an equation, 0.20x plus 15. So So that's called the algebraic representation of our problem. So now we'll try, and we're going to do this two ways. We're going to do it one way with algebra, then I'm going to show you how to do something on the calculator. We're gonna switch it around. Instead of me telling you how many miles, I want to give you how much she paid, and we'll work backwards to figure out how far did she drive the car. So it says, suppose that Sarah was charged $50 to rent the car. How many miles did she drive? So this time they're telling us $50. That's the given. Where are we going to plug that $50 in this time? What letter does that get plugged in for? Bailey?
The Y.
Which one?
The Y.
Yeah, that's going to get plugged in for the y. So now we're doing algebra. We have to isolate a variable. In the last problem, we did arithmetic. Variable was already isolated. This time it's not. So let's fill in 50 for y and see what we get. 50 equals 0.2x plus 15. And Francesca, what would be my next step to solve that?
Review first, subtract the 15.
Yep, good. I'm going to subtract 15. So that'll give me 35 equals 0.2x. And Abigail, how about my last step?
You divide by 0.2.
Yep, you can divide by 0.2. And just to make that mentally easier to think about in my head, 0.2 is a fifth. So dividing by 1/5 is the same as multiplying by 5. Same thing. So to do this calculation out in my head, I'm going to do 35 times 5, which is 175. And go back and read the question. We were finding miles. Okay, so that's how we can solve that equation using algebra. Any question on that? All right, now we're going to do something on the calculator. Let's write down that original equation that we had again. 50 equals 0.2x plus 15. Okay, and what I'm going to do is I'm going to treat these two sides of this equation. This is the left-hand side. This is the right-hand side. I'm going to treat each one of these as two separate things. So what we're going to do in our calculator is we're going to put the left-hand side of that equation in y1, and we're going to put the right-hand side in y2. And let me show you how we do that. So in your calculator, you'll turn it on. We're going to press y equals in the upper left. And once you press the y equals button, if you had something else typed in like that, you can just press clear and it'll get rid of it. So if there's anything else typed in, I would clear it so that way it doesn't mess up what we're doing. Does everyone add a screen that looks like that? Now, let's type the left-hand side in y1, and I'm going to hit enter. And I'm going to put the right-hand side in y2. Now, we got to do a couple things first, but we're going to be looking for where the picture in y1 equals the picture in y2. That's kind of a weird way to say it. What does it mean when one picture equals another picture? It's where what happens, you think? And, have a guess what that would mean? Yeah?
Where it intersects.
It's where it intersects. So we're going to look for where two graphs cross each other. Remember, these are both lines. This is a horizontal line at 50. This is a line with a slope of 0.2 and a y-intercept of 15. So let's do zoom 6. Okay, and you're going to see the yellow circle spinning in the upper right if you're using this calculator. And when it's done, we don't see anything. How come? I either didn't type anything into graph, or it did graph it, and something else is happening there. Yeah?
You have to like zoom out to see it.
Yeah, we have to zoom out. I told you this one on the left, this is a horizontal line at 50. So when you do zoom 6, you're only at 10. To get to see a horizontal line up at 50, you have to set the y-max higher. Now, what I do is I always go a little bit past what I need, so that way what I'm looking at isn't right on the edge of the screen, because then sometimes it's hard to see. So I know I only need to go to 50, but let's go to 60. Now, when you put your y-max on 60 and hit graph, okay, now we see something. There's my line at 50, and there's my other line with a slope of 0.2 and a y-intercept of 15. But can I see where they cross? No, it's further off the screen. I already know where they cross when x is 175. Normally I wouldn't know that. So what I would do is I'd say, okay, I need to look further to the right, because they're going to cross somewhere off the screen. So instead of having your x max at 10, you could try 100. We already know what's going to happen. And now you're going to see further to the right. And the lines are going to get closer. But 100 still isn't enough. So we can't do what we want to do until we can see where they cross. So let's try 200. We know that that's going to be 20. So there's the left side, there's the right side, and that's good. We can see that they cross and it's not right on the edge of the screen. It's close, but it's still on the screen. Now we want to see exactly what that point is. So there's a button we can press that'll tell us exactly where they cross. And this is how you do it. You have to press the blue button in the upper left, which is second, or whatever color yours is, press second. And then you want to press the trace button. Okay, right above it, it says calc. So you're pressing second, and then the calc. And you should get a menu that looks like this. Now, we want to see where the lines cross. So which of the 7 options there do you think we're going to use? Yeah, Jack?
Intersect?
Yeah, we're going to use intersect, number 5. So you can just press 5. And to figure out where they intersect, the calculator is going to ask you 3 things. You're going to have to hit enter each time. First, it's going to say, what's the first line that you want to use? Because you could have, and you saw when you press y equals, you can have 8 or 9 lines on the screen at the same time. So the first one that we want to use is the blue one. So we're going to use the blue one. And the only other one on the screen in this case is the red one. So once we're on the red one, we're going to hit enter. So I hit enter on the blue one, and then I'm going to hit enter on the red one. Now the calculator knows what 2 things to look at. The last thing it asks you for is a guess. So all you have to do is take your cursor and put it kind of close to the intersection. It actually doesn't matter. I'll show you when it does, but this problem, it doesn't make a difference at all. So once you put the guess, kind of close to where you think the lines cross, hit enter for the third time. And what you should see on your screen is this. It says the intersection is at 175, which is exactly what we got, 175. Okay. Any questions, or anybody have trouble getting that 175 to come up? That's the kind of thing that I wouldn't answer on a test tomorrow. If you said, oh, I don't remember the button to find an intersect. That's what I'm teaching you right now, so I want to see if you remember how to do it on your own. So I told you that the guess usually doesn't matter. Let me show you, just watch. Let me show you an example where it would matter. Let's do x squared. All right, so watch what happens with this one. Anybody have a guess at why the guess? Anybody have a thought why the guess is going to matter in this problem? Yeah.
There's two intersections.
It has two. Okay, and the calculator can only do one at a time. So if you wanted to find the one on the right, you go second calc intersect. You tell the calculator, all right, I want to find where the blue and where the red cross. So I hit enter on the blue, I hit enter on the red. And now, if I want the one on the right, I need to move my guess to the right. If I want the one on the left, move it closer to the left. So I hit enter, and it told me they cross. It gave me the one on the right. Now, you might also be like, well, why do you have to hit that like first curve, second curve thing? That's if you had more than one line on the screen. Something like this. The calculator can only work with two lines or two curves at a time. So if you wanted to say, figure out where the black and the red one cross each other, you could do second calc, intersect, and now you have to pick the black and the red. So it says right here, first curve. Blue is the one that's highlighted. If you don't have color, just press the arrow to the left and watch it move. You'll see which graph it's on. I don't want that one. So I'm going to hit the down arrow. Now I know it's on the red one because I can see it in color. Or I can press the left and right arrow and it'll show it moving on the graph. So that's one of them that I want. I want the red one. And I said I wanted the black one. I can tell it's on the black one just by moving my cursor. Now, do the red and the black cross in more than one spot? No. So then the guess doesn't matter. I can just hit enter, and it's automatically going to give me that spot right up there. And it did. It told me where they crossed. All right. So the guess is really, it's only important when you have more than one place they cross. Now, the blue and the black, you have to look at that carefully, but they do cross twice. Doesn't look like it, but I think they do. There's two spots. So that's where sometimes zooming in a little bit to see it better helps us out. All right. So that was the algebraic approach, and the bottom way is more of a graphical approach. It was this one. I can bring that back so you can see it. Okay, any questions on that? All right. So when you have, or when the directions in the book say, find a complete graph, or find a complete window, what they're asking for is a window that shows everything that's important. So for this, let me put in the last problem that we had. 0.2x plus 15 and 50. You'll notice I left that little dotted box in there. If I hit graph right now, it's probably going to complain and something weird's going to happen. In fact, it won't let me graph. It's because you left a blank exponent box. I have to hit delete to get rid of it. So for that last one that we did, I think we set the x max at 60 and the y max at 200. I must have hit something wrong. 0.2x plus 15, y equals 50. That's it. This was at 200. And that was at 60. There we go. So that window is a complete graph. The important thing you're looking for there is the intersection. So write down the x-min, x-max, the y-min, and the y-max. You may have a different complete graph than somebody else. Like if somebody said, well, what if I did 300 instead of 200? Yeah, that'll be fine. You're still going to be able to see pretty clearly where those lines cross. No issue with that at all. So the point is, when you're finding a complete graph, there might be more than one window that's an answer. What probably would not be an answer here is typing in something like 30,000. That's going to be way too big. And that's very hard for me to tell where they cross now. It's like that blue line is so squished. It's so close to the edge of the screen, I can't even see it. All right. So there's a little bit of judgment that comes with finding a complete window. I think we did that one yesterday, so I'm going to skip that one. I will mention something about this graph, though. Does anybody remember the shape of that graph? When you graph something that's squared, it has a name. Remember the name? I'll give you a hint. The type of the equation is a quadratic, but the picture has a name. Yep, Sarah? Yeah, it's a parabola. So y equals x squared plus 10 is called a parabola. And the general form of the equation for a parabola looks like that, and that's called a quadratic equation. You see those a lot, like when you're doing factoring. It'll be set up like that. That's called a parabola, and it comes from a quadratic. All right, so as we learn to graph things this year, there are two special things that can come up that we have to be careful if they come up. One of them is if you have a square root in your graph, and the other one is if you have a fraction with a variable in the bottom. Because there are certain things we're not allowed to do in math. So this one has a square root. Does anyone remember what kind of numbers are you not allowed to take the square root of? Remember, we're working in the real number system. We're not working with imaginary numbers. So what kind of numbers are you not allowed to take the square root of? Yep.
Irrational numbers?
You can do irrational, like you can take the square root of pi. It would still be an irrational number. It wouldn't be a number we could write as a fraction, but we could do it and we would get an answer. So that would be okay. Anyone have another guess? Yeah?
Negative.
Negatives. 0 is fine. A lot of people think you can't do the square root of 0. Sure you can. Square root of 0 is 0. But you cannot take the square root of a negative in the real number system. And that's what we're sticking with. So what that means in this problem is this has to be greater than or equal to 0. It can't be negative. So specifically, that means that x has to be greater than or equal to negative 20. You can plug any number you want in for x here, as long as it's greater than or equal to negative 20. If you plug in a number that's not greater than or equal to negative 20, you're going to have a problem. So the reason I wrote that down is because now when I'm finding a complete graph, this gives me a hint at how small of an x value I need to look at. I don't need to look any smaller than negative 20. The graph doesn't even exist past negative 20, going to the left. It only exists for numbers bigger than negative 20. So let's type this one in. I'm going to clear anything else I had in there. I'm going to press second, the x squared button that's on the left. That's how you do a square root. And I'm going to type in x plus 20. Everything that you just typed in should be under the root. If you ended up with like a plus 20 like that on the outside, nope, something. You got to have the 20 under the root. Okay, so any questions on getting that? All right, now let's set our window. Negative 10 isn't good enough. We have to go to negative 20. And I've mentioned before, I like to go a little bit more. Let's do negative 25. Now, there's no limit on how big of a number you can take the square root of. You can take the square root of 100, 1,000, 1,000,000, 20 million. So we need to set x max high enough that we can just see the pattern in the graph. For square roots, if you go a couple hundred numbers, that's probably good enough. And let's think about our y max. 200 is the biggest number that I'm going to show on the screen. It's not the biggest number you can plug in, but it's the biggest one I'm going to show. If I plug in 200 plus 20, that's 220, take the square root. That's about 15, roughly. The square root of 225 is 15. So I don't need to go any higher than 15, really, on the y max. Anything higher than that is a waste. But I'll just go a little bit higher so we can see. Right, and let's hit graph. And there's your square root function. It's kind of a curve. It never levels off. It does keep curving up very, very, very slow, but it will go up forever. Does anybody recognize what shape that is? Kind of? A little bit? Like almost like part of a shape? What if I did that? Yeah.
It's half a parabola.
Yep. It's half of a parabola. That's what a square root function is. It's a parabola on its side. The only way to get the other part would be as if I did something like this. You don't have to type this in, just watch. Now, by doing what I just did, I got the bottom half. Can't see it all, but it's there. Okay. But that was just the top half, just the part in blue. So for this one, I would say a complete window would be those numbers. You want to write down, that was a negative, I think it was negative 25. So write down those and those. That would be the answer to the question. And you might have something slightly different. Okay, there's more than one answer to that question. Okay. Anything else on that one? All right, so that's it for that section. So that was 1.2. So now we'll finish up with part of 1.3, which is on functions. So functions are equations, or they could be graphs if you draw them, but they're equations and graphs that have a special property. Not every graph that you draw is automatically a function. It has to have a special property. Okay, and we'll talk about what that is. So, going back to the rent-a-car problem we had this equation 0.2x, y equals 0.2x plus 15. I have an x variable and a y variable. There are different names for those variables. You can call the x the input, and you can call the y the output. Input is what you need to tell someone so that they can give you an output, so that they can give you an answer. Like if you said to me, if you sent me an email next week and said, do we have homework? That's your input. Well, my output would be yes or no. Okay, that's what I would tell you. So you'd tell me something, and I'll give you an answer back. Another name for input is domain. Domain is the values you are allowed to plug into a formula. Some formulas you can plug in anything you want, like this one. You can take any number you want and multiply by 0.2. Anything, doesn't matter. When you have something like this, you cannot plug in any number you want. For example, negative 50 doesn't work. If you try to take the square root of negative 50 plus 20, you're going to get an imaginary number. So we're not doing that. So square roots are one thing that you've got to be careful about domain. Here's another one. That's a fraction with a variable in the bottom. You can plug in almost any number you want for x, except one number. Anybody know what number you cannot plug in for x in that problem? Yep, Jake?
Would it be 4?
You can't plug 4 in. What happens if you plug 4 in?
You get 0 as the denominator.
You get 0 in the denominator, and you're never allowed to put a 0 in the denominator. You cannot divide by 0. All right? So these are the two types of things we have to be careful for. When we have a square root, make sure that we never use a negative. We never take the square root of a negative. And when you have a fraction, do not divide by 0. All right, so domain is what you can plug into a formula. Range is the answers that you get out. So kind of thinking like that homework question. If you email me and said, do we have homework next week? That could be like the domain. That's what you're asking. The range, or maybe you say it like this. Which days do we have homework next week? That's your input to me. My output, my range, could be Monday, Tuesday, Wednesday, Thursday, Friday. Any one of those 5. That's the range. It's the answers that I can give you based on what you asked me. So the range is the answer that you get from what you plug into the formula. And then another name for x, it's also called the independent variable, and y is your dependent variable. Okay, it's all different names for the same thing. So what makes something a function? I told you that there was like a special rule that made something a function. This is the rule. Something is a function if every input has one output. That means if you plug in a number, you'll get one number back as the answer. Not two numbers back as the answer, or three numbers. You get one number back. So that question, if you said, what days do we have homework next week? I could potentially give you more than one answer back. I could say Monday and Tuesday. That wouldn't be a function. To be a function, I have to give you just one answer back. Look at this one. Square root of x. When you take, especially if I did something like this. If I asked you, what is the square root of 16? What would you tell me? What's the square root of 16? That's like the domain. That's what I'm asking you. The range is what you're going to tell me. Yep. 4. And, yep, negative 4. That's not a function. Because I asked you a question, and you gave me two things back. 4 and negative 4. So y equals plus or minus square root of x. That's not a function. So a function is where every x value has exactly one y value when you plug it in and get the answer. I kind of already said that. So domain is what you're allowed to plug in. Range is the answer that you get back when you plug something in. I said that as well. We're sticking with real numbers. We'll do imaginary numbers, I think, in chapter 2. But for now, stick with reals. And there's actually two different ways that you can write a function. This is how we've been doing it, this y equals notation. You can also do that. Does anyone remember how you pronounce this f? You don't say f parenthesis x parenthesis. You don't say it like that. Anybody remember how you say it? Chris?
It's f of x.
F of x. And sometimes we use the letter G, G of x, H of x, K of x. We can use whatever letter you want. That's just the name of your equation. So this would be called equation f, f of x. Just a different notation. Any question on that? All right, so let's kind of did one like this. Well, let's do another one. It says find a complete graph. So we'll do a window on the calculator. And then using that, let's write down the domain and the range. D is domain, R is range. All right. So we can turn our calculator on. If we have anything in there, we'll clear it out. Let's type in square root of x minus 3. Once we type it in, we've got to think about our window a little bit. We know that we don't want to take the square root of a negative. So what numbers could you pick for x here? So that you at least get numbers that are 0 or higher. Like you couldn't do negative 20. That's too negative, too much. So what numbers could I pick that would result in a calculation here being 0 or higher? Chris?
Positive Positive 3?
Positive 3, and how high could you go?
You could go high as you want. You
As high as you
can't
want.
go lower than 3.
You can't go lower than 3. Okay, so you could pick any number from 3 to infinity. So the way we can, there's 2 ways we can write that. You can pick any x value as long as it's greater than or equal to 3. Or, to kind of use the bracket and parentheses, the way we learned the other day, this is called interval notation. This is your low value. So this is the low. This is the high. Whether you put a bracket or parenthesis means do you include the number or do you not include it? This is an equal to. Bracket means you can include it. It means equal to. Now on infinity, I put a parenthesis. Because when you put a bracket, that means you can reach the number and include it. Well, you can never reach infinity. So infinity always has a parenthesis, meaning you can get as close as you want, but you can never reach it. So these two notations mean the same thing. So let's type that in on our calculator. I know 3 is the smallest value, but like I said before, I don't want it right on the edge of the screen, so I'm going to do 0. What's the highest number we can take the square root of? There is no limit. Let's just go up to 100. And if you let x be 100, that would be 100 minus 3 is 97. The square root of 97 would give me a y value of about 10, a little less than 10, about 9.9 maybe. So on my y max, I don't really need to go any higher than 10. I'll do 12. All right, so let's hit graph and see what it looks like. Perfect. There's my square root, my sideways parabola. Now that I have a nice picture, I can answer what the range is. So the domain is left and right. So in this case, it's everything from the number 3 to the right. Range is up and down. What's the lowest that it looks like my graph hits? How about Isaac? What's the lowest it looks like that graph goes?
0?
Yeah, it does hit 0 right there. In fact, if you plug in 3, 3 minus 3 is 0, and the square root of 0 is 0. So yes, 0 is the lowest. And what's the highest? Think about it. This is a parabola, right? It's just going to keep going. It's never going to stop going up. So the lowest, I'll just squeeze it in down here. Lowest is 0, and the highest is infinity. That's called the domain and the range. The range is a lot easier to get by looking at a picture. Domain, usually you can figure it out without a picture. But not range. That's kind of complicated sometimes. All right, so that's that one. What else do I have? Okay, let's try this one. So x squared minus 4. Clear? Anything else you got? And we're going to press x squared minus 4. Now, you want to make sure when you do minus 4 that the minus 4 is not up in the exponent. If yours looks like this, like x squared minus 4, that's not right. It should look like this. All right, let's start start with zoom 6 on this one and see what we're looking at. Let's do zoom 6. Okay, it's a parabola. Is this parabola going to do anything else besides what you're pretty much seeing right there? Like, is all of a sudden it going to curve again or do something weird? No, parabolas don't do that. So we can pretty much see the domain and range from this picture. All right, so let's think about the domain. The domain is left and right. Think of how far this graph is going to go left and right. How far to the left is this U shape going to go? If I were to zoom out, I mean, I keep zooming out forever. Like, where would the U shape end? And then it would stop going to the left. That's what I'm asking. About Casey? What is it? Yeah, negative infinity, right? It's going to go to the left forever. It's going to get steeper and steeper, but this U shape, it's going to keep going off to the left. So it goes to the left forever, and then how about to the right? How far is it going to go? Yeah, Ashley? It's still going to go forever to the right. So the domain is all, we say that that's all real numbers. In other words, when you want to pick a value for x in this problem, you can plug in any number you want. You can square any number you can think of. And notice there's no square root, and there's no fraction with a variable in the bottom. Those are the only two things you got to be careful about. All right, now how about my range? Does this graph go up forever? Yeah, okay, it goes up forever. Does it go down forever? No, it stops. What does it look like the lowest value is that it stops at? Yeah? It's, yeah, -4. So the range is -4, and it goes up without stopping. So -4 to infinity. The domain describes the x's, range describes the y's. Any question on that? It takes a while sometimes to get good at domain and range, but I think using the graphing calculator and looking at a picture will help. Two things left. All right. So you might see a question that says something like, let me show you, like this. This means f of -2 or f of 3. So what does that really mean to do? Well, it means if they give you a particular value, take the value that they give you and plug it in. That's all that it means. Take the value that they give you inside the parentheses and plug it into the formula that you're given. And notice I said value. I think I said value inside parentheses. It doesn't have to be a number. You can plug in a letter into a formula too. Right? So I'll give you guys a formula, and then we'll try a couple examples of that, and then we'll look at our last thing for today. So I could make up any formula I want. This is the formula I chose to make up. F of x equals x squared plus 1. And we're just going to plug some different things into it and see what we get. So this would be a good problem on Edulastic tomorrow. That would be a short answer. All right, so let's just try these first three. F of -2, f of 3, and f of a. So first one, f of -2. So Chloe, if they want to find f of -2, what number am I going to be plugging into the function f?
X squared plus 1.
So that's the function we're going to plug into, and what are you going to replace x with?
-2.
-2. Right? So f, I'll write it right below each one. F of -2 equals, I always put it in parentheses like that, plus 1. Okay, so Devin, what's -2 squared? So careful, you're squaring that negative with it. So it's a -2 times another -2. So 4 plus 1 gives me 5. That's how you do f of -2. Okay, f of 3. 3 squared plus 1, which in this case is 10. Now, f of a, there's not really anything I can do. I just fill the a in where the x is, and that's all I can really do. A squared plus 1. Okay, so that's called evaluating. Any question on that? Okay. All right, so last thing. So not every equation is a function, and I gave you guys a description of what had to happen for it to be a function. Every input had to have one output. That means you plug a number in for x, you get one answer for y. Some people like to think of that more visually. I already wrote this down earlier. So this type of thing is not a function because you get two answers. There's a name of a test you can use. Okay? It's called the, anybody remember abbreviations or VLT? Anybody remember what that stands for? Yeah?
Vertical line test.
Yeah, it's called the vertical line test. And the vertical line test is used to determine if something is a function. So the vertical line test says that if you have a picture, let me draw the square root one. If you have a graph and you take a vertical line and you put it somewhere in your graph, if the vertical line can hit the graph more than once, then what you just drew is not a function. This hits in two spots, so it's not a function. How about something like this? There's my x and y axis. Looking at that wave, is it a function or not a function? We use the vertical line test to determine it. See? Yeah. All right. So you're saying if I draw a vertical line, it will hit it more than once? No. If I put a vertical line in that graph, no matter where I put it, it never hits the graph more than once. Maybe just to be clear, that's the graph. The other black lines in that picture are my axes. If I draw a vertical line, the red curve and the red line, they never hit more than once, no matter where you put it. So that means it's a function. How about a circle? Would a circle be a function or not a function? It's not a function, because a vertical line hits it more than once. That's called a vertical line test. All right, so what I'll do is let me put up the homework. And then while you guys are copying that down, I will make a list of topics that are on the test for tomorrow. All right, so let's take a look at the topics that are on the test. So we talked about the distance formula and the midpoint formula. Okay, that was in section 1.1. How to graph on a number line. Okay, so that involves like an open circle, closed circle. It could be a shade in one direction or shade between if it was a conjunction. Talked about absolute value. Okay, how do you find the absolute value of a number? You should know how to set a window on a calculator. So the way I would test you on a question like that is I would give you a graph and I would say, here's the window I want you to use, and I'll give you 5 pictures. And you tell me which picture would be the correct one if you set the window the way I asked you to. Finding the domain. So remember there, the 2 things you want to be careful of. You want to be careful with, you want to have no square roots of negatives. So something like this. I'm not saying you can't let x be negative. You can let x be -1 right there. That's no problem at all. Because then you're adding 3 to it. That's going to make it positive. What you couldn't use in this case would be something like -4, -5. That's too small. Okay? So you have to make sure you avoid having a square root of a negative, and you cannot divide by 0. So if I gave you a problem like, and I said to you, what's the domain there? You could say that it's every number except, what number can you not use there? Yeah. 8. So one way you could write that would be the domain, it might be a box online that says something like this, domain, and then a box, and you could type in something like x would be every number except 8. That's one way to write it. Evaluate, we just did that. So if I say find f of 2, you know that means take 2, plug it in, and give me the answer. You should know how to find the range. So again, that's where we looked at it on the calculator and looked how high and low the graph went. And determine if something is a function. So that's where you can use the vertical line test. And the answer would be yes or no, or true or false. Okay, so those are the main topics that are going to be on the test. It'll be about 16 or 17 questions. Be a mixture of short answer and multiple choice. Okay. Anyone have any questions on the test or the topics yet?
On Monday, did you say that we could use a like a note sheet for test or not?
Yes, you can have a reference sheet. This size paper or smaller, 8.5 by 11, handwritten. You can use both sides, and you can put anything on it. Formulas, definitions, examples, anything like that. Yep. Yes?
I know you already went over this yesterday for the homework, but can you re-go over how to do the absolute value when it's like 2 minus the square root of 5?
Yeah, so let me pause this, because we're all set with that video.